That's 27. 27 to the power of n minus 2 times 6 to the power of n all over 162 to the power of n. Okay, so that's the question there. Now, when you are doing this question, as I told you yesterday and the day before, you must convert all your bases to prime bases first. So I have to convert the 27 to a base of 3, that's 3 cubed, raised to the power of minus 2 times 6 is the same as 3 times 2, and that raised to the power of n all over. 162 is the same as 81 times 2. Okay, and we know that 81 is the same as 3 to the power of 4. So this becomes 3 to the power of 8, right? All raised to the power of, it's 3 to the power of 4 times 2. Okay, this will be 3 to the power of 4 times 2. Because 3 to the power of 4 is equal to 81. 81 times 2 will give you 162. Alright? Then, from here, you now need to use the first fit. You have to remove the brackets. So I have converted all bases to prime bases. Generally, you get 1 mark for converting all bases to prime. Once you have done that now, you have to use your knowledge of brackets, then use first law and second law. So here, I want to emphasize to you that for the first base, which is a 3, that 3, which is an exponent, multiplies both n and minus 2. Okay? I've seen in the past learners forgetting to multiply this exponent by that constant minus 2. They will just multiply the 3 and the n only. Now, don't make the same mistake. Right? So here, I have to say 3 to the power of 3n minus 6 times 3 to the power of n times 2 to the power of n all over 3 to the power of 4n times 2 to the power of 2n. Okay, so that's the next step. So convert all bases to prime, then remove the brackets, and then you simplify. So the next thing that I'm going to do now is to use law 1 and law 2. Okay? Use law 1 and law 2. If you are multiplying the bases, you add the exponents. If you are dividing the bases, you subtract the exponents. Now before I carry on, I'm sure you can see that we have 2 to the power of n here, and we have got a 2 to the power of n there. Now those two are going to cancel out, and that will make the question very easy. So in my next step, I'm going to write 3 to the power of 3n minus 6. Now, because of this base here, or the multiplication, I'm going to add the exponent there, so it will be plus n. And then this exponent is part of the denominator, so I'll subtract it. Alright? Then from here, we have 3. Now, 3n, this 3n plus n will give me 4n. 4n minus 4n will give me 0. So I'll end up having 3 to the power of negative 6. And that 3 to the power of negative 6, I can divide it as 1 over 3 to the power of 6. Okay, I'm not going to ask anyone anymore into the group, into the meeting. All right. So, what is 3 to the power of 6? 3 to the power of 6, remember, it is the same as 27 times 27. So what's 27 times 27? Can someone tell us the answer? It would be 1 over what?
1 over 7 to 9, bro.
1 over?
729.
759.
29.
Yeah, it will be 729. Thank you for that. So that's your final answer. Okay. I hope that you were able to get that answer because it's not that complicated. Okay? Any question?
No, sir.
Okay, let's move on to exercise 12, question 7. Exercise 12, question 7. Right. Exercise 12, question 7. So this is exercise 12, question 7. So we have 3 times 10 to the power of 4x minus 6 times 10 to the power of 3x all over 3 times 10 to the power of 3x. Like that. Okay, now if you look at this question now, because we have got a subtraction of exponential terms in the numerator, right? We have to identify a common factor. Since we have got these integers, that is this 3, that minus 6, that 3, we have to determine the highest common factor based on this 3 here. So I'm going to take out 3 in the numerator as a common factor. Furthermore, if you look at the exponential terms, 10 to the power of 3x, we have 4x there, and here we have got 3x. So what that means is I need to identify my common factor for the exponential terms, and that common factor is going to be 10 to the power of 3x. So I have to split that 4x into 2, so I'll write it as 3x plus x. So my next step is to say, before I take out the common factors, I'm going to write this 10, 3 times 10 to the power of 3x plus x. Okay? Minus the 6, I can write as 2 times 3. All raised, this is multiplying 10 to the power of 3x. All over. The denominator is 3 times 10 to the power of 3x. Alright, so from here, I can now take out my common factor. So for the integers, it's going to be a 3. Then for the exponential terms, it's going to be 10 to the power of 3x. Remember, this 10 to the power of 3x plus x is equal to 10 to the power of 3x times 10 to the power of x. Okay? So that's how it is. So I take out the common factor and I write that as open bracket. That will be 10 to the power of x minus 2. I'll get rid of the 2 there, like that. Okay? Because remember, you can see it as well. I took out that 3 as a common figure, the 10 to the power of 3, so I'm left with a 2 inside the bracket. Then the denominator is exactly the same as the common. So in the end, this common factor and that denominator are going to cancel out. And the final answer is going to be 10 to the power of x minus 2. Okay? And that will be it. Okay. Any question?
Sir,
Yes.
I'm still having trouble like understanding, how we took out 3 times 10 to the power of 3x, and in the brackets we only have 10x minus 2. What about the 10, this 10 to the power of 3x at the end? Do we not include that?
Okay, look here. Remember, the bracket also represents multiplication. I hope you are aware of it. So maybe if I write this, but let me rewrite this for you in a way that probably might make it easier. So I can write this as 2 times 3 times 10 to the power of 3x. Okay? Because this 6 is the same as 2 times 3. I can write it as a product of its prime factors. Why did I do that? Because at the beginning here I've got that 3. Okay? And I saw that I can write 6 as 2 times 3, which means I can create a common factor. This 3 and that 3, they will become, will make it to take out 3 as a common factor. Then here, I explained to you that this is the same as that. So 4x is the same as 3x plus x. Why did I do that? Because in the denominator, I got this 10 to the power of 3x. So if I want to take out a common factor, I have to create here. I have to create 10 to the power of 3x. So that I'll end up having 2 common factors. The 3 and the 10 to the power of 3x. Are you getting it?
Yeah, okay, I think I understand.
I hope so. So just look at this. Look at what I wrote here. That's very important. Okay? By doing this, I created that common factor, which is 10 to the power of 3x, which is the same as this denominator. All right? Okay, so your final answer will be that. Okay, can I carry on?
So,
Yes?
is there a specific method in which you use to factorize?
Well, okay, to be honest with you, in this case, there is no other method because you have to create the common factor. You have to create the common factor and identify that common factor. So I would say first you have to identify the common factor and try to create the common factor. So here I saw that the exponential terms, but before I carry on, I just want to remind you, if I give you 10 to the power of 4x and 10 to the power of 3x, what's the highest common factor of those two exponential terms?
Highest common factor.
What is the highest common factor of 10 to the power of 4x and 10 to the power of 3x?
10 to the power of 3x.
Yes. So that's why I did this. To create this 10 to the power of 3x because it's going to be my common factor.
Yes, sir.
Right? Okay. Let me move on to the next question. If you have got a major challenge, then you can see me on Tuesday when you come back. Then you can talk maybe face to face. But the basic idea won't change. You still have to determine the highest common factor of the exponential terms. Okay? You still have to determine the highest common factor of the exponential terms. And I told you in class, if you are given, say, a cubed, a squared, and a, like that, the lowest common multiple of these three is going to be a cubed. the highest common factor is going to be A. Okay, so make sure you know that. All right, let me move on to the next one. So the next one, that's question 9. We have 3.03 times 10 to the power of negative 3 plus 0.90 times 10 to the power of minus 3 all over 3 times 10 to the power of minus 4. Okay? So here, I want you to be aware that again, I'm going to use the same concept that I used. But be very careful in this question that we have got this 10 to the power of minus 3, we have got 10 to the power of minus 3 there, and then we have got 10 to the power of minus 4. Alright? Now, I want to ask you a question before I carry on. What will be the highest common factor of 10 to the power of minus 3 and 10 to the power of minus 4? What's the highest common factor of those two?
10 to the power of minus 3.
No. No. Okay, which one is greater, 10 to the power of minus 3 and 10 to the power of minus 4? Alright, I hope that you all have calculators in front of you. 10 to the power of minus 3 is the same as 1 over 10 to the power of 3. And 10 to the power of minus 4 is the same as 1 over 10 to the power of 4. Furthermore, this is the same as 1 over 1,000, and that's 1 over 10,000. Which one is greater? 1 over 1,000 and 1 over 10,000?
1 over 1,000.
Huh?
Yeah, 1 over 1,000.
It's 1 over 1,000. Okay? It's 1 over 1,000. 1 over 1,000 is greater than 1 over 10,000. So, if I want to find the highest common factor of those two, all right, it's going to be 10 to the power of minus 4. Okay? So, my next step would be to say 3 times 0,
Sorry, sir.
3,0.
Wouldn't
What?
10 to the power of minus 4 be the lowest covering multiple?
Remember here we are talking about negative exponents. Okay? 10 to the power of minus 3 is greater than 10 to the power of minus 4. Therefore, the highest common factor of those two is going to be 10 to the power of minus 4. It's going to be the one with the smallest exponent. That will be the highest common factor. Remember, which one is greater, minus 3 and minus 4?
Minus 3.
It's minus 3. Therefore, when we are finding the highest common factor, we take the smallest of the two as our highest common factor. But if you are taking the lowest common multiple, we take the largest of the two.
Okay, I understand now, sir.
Okay, so here I can write this 10 to the power of minus 3 by saying 10 to the power of minus 4 plus 1. Okay, because minus 4 plus 1 will give me what? Will give me negative 3 plus 0.90 times 10 to the power of minus 3. Alright? Now, sorry, I need to write this as minus 4 plus 1. Right? All over 3 times 10 to the power of minus 4. So I'm creating the common factor, which is 10 to the power of minus 4. Okay? By doing this, by doing that, wait. By doing this, I'm creating the common vector. Now, I hope you understand that part. Okay? Right, then from there now, I can split that up and write this as, before I take out the common vector, 3,03 times 10 to the power of minus 4 times 10 to the power of 1. I'm now using law 1, moving from the right hand side to the left hand side, plus 0,90 times 10 to the power of minus 4 times 10 to the power of 1, all over 3 times 10 to the power of minus 4. Okay? So you can see now that I've got my common vector. So my next step, I'm going to carry on the next page, is going to be 10 to the power of minus 4 times 3,03. Okay? I'm taking out the common vector times, this will be times 10 to the power of 1 minus 10 to the power of 1, all in brackets, all over 3 times 10 to the power of minus 4. Okay. Then, as you can see, because of this multiplication, this one cancels with that. Right? Now, 3,03 times 10 will give us 30, 3. So we end up having 30,3 minus 10 all over 3. And this will give me 20,3 over 3. Now I can simplify this further and convert it to an improper, to a common fraction. Okay, I can convert to a common fraction. So the 20,3 is the same as 20 and 3 over 10, right, all over 3. Now, remember you did fractions, so you are expected to know how to deal with fractions in this grade. So from here, I can write that as 203 over 10, right, divided by 3. This is going to be equal to 203 over 10 times 1 over 3. The denominator there is a 1. So my final answer I can write as 203 over 30. Okay, I can write it like that. If you want, you can use the calculator and simplify it. You get 6 comma something. What will be the answer to 2 decimal places?
So,
Yes.
I have a question. Why did we give out 0.9
Sorry, can you come again?
factor?
Why did I what?
Excuse me?
Oh, okay,
Give out
sorry.
0.9.
All right, sorry. I think I made a mistake there. I forgot that. Okay, let me start afresh. Sorry, thanks for that. I have to include that 0.9 because thanks for that. You should have told me earlier because I'm rushing now because of time. Okay. I'm so sorry for that. I forgot to put the 0.9. Thank you for that. I'm going to restart. You should have told me earlier how to put it. Okay. Thank you so much for letting me know that I forgot to put 0.9. Okay. So what I'm going to do is I'll put it here because on the previous page, I wrote it right here. It's here, right? So I need to put it here. So this will be 0.90 times 10 to the power of 1. Right? This is over 3 times 10 to the power of minus 4. Okay, so that one cancels with that. Then this will become, now 3,03 times 10 will give you 30,3 minus. This 0,9 times the 10 to the power 1 will give us 9, that's all over 3. And then you end up getting 30,3 minus 9, which will give you 21,3 over 3. Alright? Now, this is very interesting because it will make the answer much better than what it was previously. So I can convert the 21,3 to 21 and 3 over 10, that is all over 3. Then I'll carry on here, that will give me 213 over 10 divided by 3 over 1. And that will be 213 over 10 times 1 over 3. So the final answer will be 213 over 30. Can you convert that to a decimal? Is it fine now, right? It's fine now, isn't it?
Yes, sir.
Okay, thank you. So, can you convert this to a decimal for me? 213 over 30 to 2 decimal places. What's the answer?
7.1.
So it will be 7,10. I said to 2 decimal places. Hello? To 2 decimal places, it will be 7,10. Okay. So that will be the end of today's lesson. So, is there anyone who has got any question?